I'm going to wait that people come into the room and take a seat. So, good morning, everyone. Thanks for coming here. And my name is Rocío. I'm a postdoctoral researcher here at the University of Valladolid within the project Escalera de Excelencia. And I'm going to present some preliminary results of our study about the drivers of car accidents caused by collision with ungulate species in collaboration with the NIA. So ungulates are keystone species in many ecosystems, but as Thomas has said, the population increments experienced in the last decades over many regions of Europe have led to very high population numbers that causes important damages in crop and forestry production, transmission of disease to livestock and humans, and also increased risk of causing traffic accidents. For example, here in this region, Castilla y León, car accidents caused by collisions with the red deer, the roe deer, and the wild boar has experienced notable increments between 150 and 300% in the last decade or so. And I guess that all of you will agree with me that traffic accidents is a major societal issue, and so too thinks the United Nations, which has established the goal of reducing car accidents by half by the end of 2030. But as the scientists state in a letter published in Science, there is no specific strategy to reduce car accidents with animals. And going back again to the case of Castilla y León, indeed there has been a decline in the number of car accidents, which has declined by 44%, while accidents caused by collision with ungulate species have increased by 225%, which is a lot. So understanding the factors, quite impressive, right? Understanding the factors that causes collisions of this species with cars is very important to implement effective management actions. So in our study, we will explore the relevance and the effects of anthropogenic and environmental factors that can influence the probability of car collision with the wild boar, the red deer, and the roe deer, which are the most common species, probably in Spain and also in this region. So we know that the temporal pattern of collisions change with the species and over the years, so we will explore whether there is a seasonal variation in the effect of the different factors studied. So for our analysis, we use data from ungulate car collisions from official records here in Castilla y León for the period 2015 to 2020. And we restricted the analysis to this period of time because we wanted to use maps of species density published in this report of NET Wild, in which the authors estimated the density of these three species using hunting back records from this time window. So the variables we used to predict the probability of having a car accident with this species are, of course, species density, slope, altitude, the proportion of different habitat types, an index of landscape diversity, mean patch size, road density, and the day of the week when hunting can occur in this region. So we calculated the value of all these variables within a circular buffer of 500 meters around each collision point, and also around a set of random points generated in the entire road of networks of the region to compare the features between location of accidents and those random points. So I also use random forest to determine the relevance of these factors, which is a machine learning technique based on the averaging of multiple decision trees and is a widely used technique for classification and variable selection. So our response variable is a binary variable, traffic accident point versus random location. We split the data set in two subsets, 70% of the data for model training and 30% of the data for model evaluation. And because we were interested in this seasonal variation, we built one random forest model per species and season, considering 4 seasons: autumn, winter, spring, and summer. So let's go to the results. So in the case of the roe deer, which is the species which concentrates the highest number of collisions with cars, we can see that the species density is the most crucial variable in the random forest models. And this is, we can see that this value is the model fit, and the model fit is particularly high for spring and summer, which are the seasons when most car accidents concentrates. Then we had road density and slope, followed by altitude as very important variables in the model. Then we have a bunch of variables related to habitat, composition, and structure. And hunting day is a very relevant variable in the model. In the case of the red deer, we again see that the species density is a relevant variable, but its importance is mostly concentrated during summer, when the species starts its breeding season, and during autumn, when hunting activity occurs. But, hunting day, again, is a very poor variable for model classification. Again, we see that road density, altitude, and slope are very important variables in the model. And this is particularly evident during autumn, where you can see that there is a very clear segregation between these topographic variables and the other ones related to habitat structure. This is interesting because in spring, SRAB is or the proportion of SRAB is a very important, well, quite relevant variable in the model, but then during the summer it is replaced by arable land. So finally, for the wild boar, we see that road density is a very crucial variable, most particularly during autumn and winter. Again, altitude and slopes emerge as very relevant variables. Also species density, which is particularly interesting. That is the most relevant variable in summer. Forest is a quite relevant variable in the model building during autumn and winter, but then it is replaced again in spring by SRAB and in summer by arable land. So our very first conclusions are that road density, altitude, and slope are among the most crucial variables affecting the probability of having a car accident by collision with this species all over the year. Species density is also a very relevant variable, but it depends on the species and also changes with the season. The proportion of SRAB has a quite important effect on collisions with the red deer and the wild boar during spring, but then arable land emerges as a relevant variable related to habitat during summer, which in Mediterranean areas is a period of food shortage, and animals need to find food, and arable land offers, well, it's a good option for them. And finally, hunting day has no effect on the model, but this could be caused by an inappropriate spatiotemporal scale. So what's next? We want to include variables related to traffic intensity. We already have the data, but we need to prepare the data sets. I want to check on road sinuosity. This is a very interesting variable, but I had some troubles with the shapefiles, and I need to work on that. Of course, evaluating the relationship between the environmental features and the probability of having a car accident with this species. And we are trying to gather information, more fine data on hunting occurrence, and trying to explore whether there is truly a link between hunting activity and the probability of having a car accident with this species if animals change their movement pattern. So thank you very much.